Well, hello. I wanted to do some applications now for the product and the quotient rule. They're both of them going to look like quotients, but these are really good application problems for you to look at. And here I have this function, g of x. It's 1 over x squared plus 1, and I want to know when it's concave up. Okay? So remember we talked about concavity is your second derivative. So I basically want to know when g double prime of x is positive or greater than 0. So we're going to go through all the same work you would if you wanted to know about increasing and decreasing, but all I want to know is when is this concave up. So first thing is I've got to do derivatives, and I'm going to do g prime of x, and I'm going to set up over here all the work. So here's my f and here's my g. So f is going to equal 1, g is going to equal, well, excuse me, I'll put the g over here, I like it better that way, is x squared plus 1. And then f prime, of course, because that's a constant, is going to be 0, and g prime is going to be 2x. All right. So if I was going to do the quotient rule, we know that it's f prime g minus f g prime all over g squared. So let's find g prime of x. So f prime g, if you'll see that first term will cancel, minus 1 times 2x, so that's minus 2x all over g squared. You're like, well, this isn't bad. And you're right, it's not. And we don't have to do anything with it because they didn't ask us anything if the function's increasing or decreasing. Now what happens with the work is now we got to do the second derivative. So I'm going to set it up over here. Now my f is going to be negative 2x, and my g, whoops, so this should be squared, sorry, I forgot about that. And my g is going to be x squared plus 1 squared. Okay? So let's do the derivative so we can do this. So f prime here is negative 2, that's pretty easy, but now g prime, we actually have to multiply this out so we can take the derivative. So if I did this side by side and did x squared plus 1 again and got rid of this, okay, now I have, if I'm multiplying this out, x to the 4th plus, then I have x squared plus another x squared, 2x squared plus 1. Now I should actually, this is not g prime, that's just g. Now g prime is taking the derivative, is 4x cubed plus 4x. Okay? Now, I am actually going to factor this to see if this will help a little bit. So let's take out a 4x here. So I have x squared plus 1. So let's see if that helps. You could use this right here, but I want to see, because I see this x squared plus 1 over here, I'm wondering if maybe something will cancel. So now I got g double prime of x. It's going to be the same. It's going to be f prime g minus f g prime over g squared. So I'm going to do f prime times g, so I have negative 2, and I'm going to use the factored form, okay? So I've got negative 2 times g, and I'm going to use it like this because I'm hoping something will cancel, minus f g prime, so I'm going to do minus, and I'm going to do this, negative 2x, okay, g prime, and I'm going to use this bottom one. Now this actually turns to a plus, so I'm going to kind of go a couple steps here, because sometimes when you go too fast, and then I got g squared, so this is what it is, and I'm squaring it. So I'm going baby steps. I know you could write that to the 4th. So it's g double prime of x is going to equal negative 2 x squared plus 1 squared, and then it's going to change to plus 2x, because negative times a negative, and I'm going to actually multiply that as 4x cubed plus 4x. I'm going very slowly over x squared plus 1 to the 4th. This is what I mean by going fast slowly. If you take your time, you won't make goofy mistakes. Now, I am looking at this as a term, okay, right here is a term, and this is a term, okay? And I think, well, I wonder if there's something I can factor out of this one more, because this one's all set. So I have g double prime of x. I'm going to leave this alone for right now. And then I'm going to factor even a 4x out of here. So if I factor a 4x out of here, this will be plus 8x squared, and then I just have a x squared plus 1 in here. I'm going to show you why I did this in a minute. X squared plus 1 to the fourth. Okay, so let's review. I have a term here and a term here. I see this is something I could cancel. I wonder if there's something I can do here, because you can't just do one, you have to do both. So what I did was I looked just at this term and I see, oh, I can take a 4x out of there. So when I did, that turns to 8x squared, and then this is x squared plus 1. Now I'm pretty pleased, because now here is a term right here, and here's a term right here, and they both have in common an x squared plus 1. So I'm going to factor this out. So if I factor out an x squared plus 1, and I also can take out, if you look, I'm going to take out a negative 2 to make life easier. So I'm going to pull out a negative 2 x squared plus 1 out of this, out of both terms. Now if I take it out of this one, all there's left is an x squared plus 1. If I take this out, this changes the sign, okay? And the x squared plus 1 I already took out. So if I take negative 2 out of 8x squared, that is a minus 4x squared. All over x squared plus 1 to the fourth. Now if you need to go back and redo some of this to see where I'm getting everything, please stop the video and go back. So I want to show you what I did. I took out a negative 2x x squared plus 1 out of both of these terms, okay? So when I take it out of here, obviously there's only one left. As you see, it's right here, x squared plus 1. Now if I take this or divide this out, because when you factor it out, you're really dividing. This x squared plus 1 over x squared 1 is a 1, and then I have 8x squared divided by negative 2 comes out to be a negative 4x squared. All right. Now I'm going to combine everything in my parentheses there. So I have g double prime of x is negative 2 x squared plus 1 times, and when I combine everything in here, it's a negative 3x squared plus 1. To the fourth. Okay, now I see now that I have a factor, and I have a to the fourth term here. So this and this can cancel, but what it will do is do this. I'll say, okay, thanks for playing. This will go down to a third. So this is actually comes down to be g double prime of x equals 2 times negative 3x squared plus 1 all over x squared plus 1 cubed. All right. Now we did all that work to, we have to set this equal to 0 because I got to find out when it's concave up and down. All right. So I'm going to kind of do some of this over here a little bit. Even though I know we have this whole page, I just want to make sure I have enough room for the graph. So I think I'm going to put the graph here, and we'll fill that in later. So we got x and y. And all we have to write here is f double prime bar, because that's all they wanted to know. Alright, so let's keep going. So I have g double prime of x, excuse me, now it's equal to 0. Now when I go to solve this right here, okay, put this over a 1 and cross multiply. So if I cross multiply, as you'll see, this will disappear, and I'll have this equals 0. So I have 2 times negative 3x squared plus 1 equals 0 when I cross multiply. All right. Now I'm going to divide by 2. So if I divide by 2, I have negative 3x squared plus 1 equals 0. And if I move the negative 1, I have negative 3x squared equals negative 1. Divide by negative 3, I have x squared equals a positive 1/3. And you have to remember, when you have a squared term, when you take the square root, it has to be plus minus. So x is going to equal a positive radical 1/3, and x is going to be a negative radical 1/3. So that tells you, oops, sorry, a negative radical 1/3. So that shows on our graph here, which is a very small number, by the way, is I have a negative radical 1/3 here and a positive radical 1/3 there. All right. Now I want to find out when it's concave up and down. So if I go to the left, and I always tell you to go to the factored part here, so we're going to look at this right here, that if I go to the left of negative radical 1/3, so let's say we pick a negative 1, for example. So negative 1 squared is positive 1. Negative 3 times a positive is negative, plus 1, and this is negative. So I look at here and I said, okay, so I want to go to the left, and if I put that in there, oh, let's try 0 first. If I put a 0 in here, this would be negative, okay? Because it's negative 3, and I put a 0 in there, and I turn this over here, I've got this positive 1, it's going to be negative. So it's going to be negative in the middle. And then on the left of this, if I put a negative 1 in here, okay, that turns positive, and a negative, this turns positive. I misspoke myself before. And if I go to the right, like if I put a 1 in here, okay, a positive 1 in here, this would be negative, negative, so this also comes out to be positive. Now, if this makes you uncomfortable and you're not for sure how I did that, you can always put your second derivative, which would be this whole thing, in your calculator and look at the numbers on the left and right of this. So if you look at it, and the other thing is the graph kind of looks like this. So let me see if I could draw it. So it's obvious that in the center it's concave down, and it kind of curves up on it, so it's concave up on the left and right. So this is what this means, concave up, concave up. So now my answer is going to be as follows. I can say x is less than negative radical 1/3, or x is greater than positive radical 1/3. I prefer interval notation, negative infinity to negative radical 1/3, in union with radical 1/3 to infinity. So there's our answer. Now that was a lot of work to get there, so this takes practice, so you'll probably have something like this to practice for your homework. Okay, let's look at one more. And I went too far, okay. It says find the equation of the tangent line to the graph f of x. And another one, this is another quotient rule, and we're looking for the equation of the tangent line. So the first thing I think of when I do this is y minus y1 equals m x minus x1. So what do I need? Well, I need a point and I need the slope, and the slope is going to be the first derivative. So basically we're going to find the first derivative. Before we do that, though, how about we look and see where the point is? And they said they want it when x is 1. Okay? Well, what is the y? I need a y. So what you're going to do is plug a 1 in here. So we're going to find f of 1 so that I can figure out what the y would be. So that's going to be 3 times 1 minus 4 all over 1 plus 1. So that's going to be negative 1 over 2. So now I know the point is 1, negative 1/2. That's important. So now I know the point, okay? I can't say that's half the battle because we got to find the derivative yet. So we have to find f prime of x. And again, this is our f and this is our g. Okay, so let's set up the work here. So I have f is going to be 3x minus 4. F prime is going to be 3. G is x plus 1. G prime is going to be 1. Now, let's do the derivative. So it's f prime g minus f g prime all over g squared. So let's plug it in. So I have f prime of x equals f prime g, so it's 3 times x plus 1, minus f g prime, so that's minus the 3x minus 4. And please note how I always put the second in parentheses because of that negative sign, all over g squared. And I don't think I can factor anything out of there, so let's multiply that out a little bit. So I have 3x plus 3 minus 3x plus 4 all over x plus 1 squared. The 3x's cancel out, so now I end up with f prime of x is 7 over x plus 1 squared. Alright, so we found the derivative function, but we want to know the slope of our line. So you're saying, okay, derivative slope, but we want to find it when, right up here, when x is 1. So we actually have to find f prime of 1 to see what the slope is at 1. Don't ever put the x's in your equation. But this is the derivative function. That is correct. So I do 7 over 1 plus 1 squared, or 7/4. That is our slope at 1. So now we're going to plug everything into our equation up here. So we're going to use this, and we're going to use the point you found. So I have y plus 1/2, because I'm going to put a negative 1/2 in there, equals the slope, which you just said is 7/4 times x minus 1. So y equals 7/4 x minus 1 minus 1/2. So there is our answer. There's our tangent line. Okay, this was a couple of long problems that you had to do with the quotient, the product and the quotient rule.